Okay, the objective of this video is just to briefly go over the Fortinet SD-WAN and AD-VPN capabilities. It is not intended to be a full-blown marketing pitch. It is a functional, technical video, obviously aimed at those more technical in nature who want to get a better grasp of what the platform can do and how it operates. So the topology that we're going to be working on is a kind of representative of most, or of a typical, I suppose, branch and data center environment where I've got two data centers up here at the head end representing two geographically dispersed data centers, and then three regional spokes all connecting into the internet. The spokes are two IPsec tunnels emanating from each spoke, with each tunnel terminating respectively on DC1 and DC2. Now, the takeaway here from an SD-WAN perspective is that we are in no way bound to using the overlay tunnels. The SD-WAN, the whole auspice of SD-WAN is that you can take multiple physical connections as well as logical connections, and you can choose any of them in combination or in isolation to steer application traffic to meet business demand or quality of service or whatever the case may be. All right, so that's one of the things just to bear in your mind, that the Fortinet SD-WAN is not bound to any sort of overlay model, nor is it bound to any sort of a controller. Now, we do have a central management plane which is used to orchestrate the SD-WAN, but it is the SD-WAN by itself, as will be shown, can be locally significant. It can be configured directly on each box, and it can be 100% locally significant. So remember that we are not bound to any sort of overlay, nor are we bound to a controller-based model. These are all options that can be used. The platform is very flexible. So if we just come along here to the actual system, we'll start off here with the FortiManager. The FortiManager is a central management platform, single pane of glass that allows us to manage all the aspects of what's termed a Fortinet fabric. A fabric is a Fortinet device which is managing multiple Fortinet components, for example, our switches and our access points. So depending on the size of FortiGate you have, it will depend on how many switches and access points it can manage. But just to give you an idea, the largest FortiGates can manage up to 300 switches and up to 4,000 wireless access points. So to put that in perspective, from one IP address, from a single firewall, we can manage over 14,000 Ethernet ports. And as I said, up to 4,000 access points. But the FortiGate as a device is more than just a firewall. It is a multifunctional security gateway. And if we just look at the features and functionality that's available on a FortiGate, it's truly astonishing what this platform can do. And really the strength here comes in its ability to consolidate multiple devices and functions into a single platform. And what's really cool is that all of these features are included in the purchase price of the platform. So the only thing that typically gets charged for on an ongoing licensing basis is the threat intelligence feeds. So your antivirus, your web filtering, your DNS filtering, your application control, and your intrusion prevention. In fact, the application control is now included in the base license of the platform as well. So as I said, it is a multifunctional device. If you want to do routing, it does supports advanced routing, so BGP, OSPF, RIP, and so forth. ISIS is also supported, but configured from the CLI. If you want it to be a switch controller, if you want it to be a Wi-Fi controller, VPN is built in. That's both SSL and IPsec. And as I said, if you want to know more about the capabilities, please reach out to your respective Fortinet representative. But today, as I said, what we're going to be doing is focusing on these features, the SD-WAN features, and the IPsec features, which are the AD-VPN, which is, it's not, you don't have to use AD-VPN. It's auto-discovery VPNs with SD-WAN, but it certainly makes the provisioning of an IPsec environment far simpler, because you do not have to create a full mesh environment. So in essence, if spoke 1 here wants to speak to spoke 2, what happens is spoke 1 will reach up to the data center. The data center will respond back to spoke 1 and say, hey, listen, you don't have to come through me. You can speak directly to spoke 2. It sends down spoke 2's relevant details, pre-shared key, external IP address, and so forth. And spoke 1 simply sets up a dynamic tunnel to spoke 2 for the period of time that the application or traffic needs to flow. It can stay up permanently if you configure it to, but otherwise it'll tear it down once the tunnel has been idle for a period of time. And in essence, the underlying way that this functions is by leveraging BGP. There is another well-known tunneling or dynamic tunneling, VPN tunneling system, which has been around for a long, long time, but that relies on something called next hop resolution protocol. We don't need that. We use good old-fashioned BGP, which is a well-known protocol. It's what the internet runs on. It's stable and it's very feature-rich, so it kind of makes sense to use that. In this case, DC1 and DC2 act as route reflectors, and that's how they learn about the downstream subnets or the local subnets of all these devices. They know which device has announced it from the external IP address, and therefore they, when, as I said, spoke 1 reaches out or sends traffic relevant to spoke 2, the route reflector here already knows all about spoke 2 and can then respond down to spoke 1 with the relevant information as to how to get to spoke 2 or spoke 3, whatever the case may be. So we'll start off there. So very briefly, if I come along here and I go configure router BGP and I do a show here, we can see here that I'm running BGP. I can see my autonomous system number. I can see my router ID. But here is where I've configured a neighbor group. Now this neighbor group allows me to have multiple neighbors form an adjacency with this without me having to manually specify each remote neighbor's IP address. And you can see here that we have got the route reflector enabled here, and here's my neighbor range. So basically anything coming in with those with the subnet /24 will be accepted as a neighbor peer. Let me just close that down. All right. So if we look along here and we go to our routing monitor, we'll see that I've got my BGP adjacencies up here. I'm using IGP as my underlying, OSPF as my underlying IGP for reachability across my virtual internet. Obviously, in a real internet world, you wouldn't be doing that. You'd have a default route, and that would allow the devices then to reach out via the next hop gateway to discover the path to get to their VPN peers, but OSPF is just simple for me to use in this environment. But as I said, the important thing here is the BGP, and if I look at the VPNs here, IPsec tunnels, you will see that I have got 3 active tunnels, which is representing my my 3 spokes. All right. So there's my tunnels, and if I come to my spoke and I go monitor IPsec tunnels, you can see here that as I mentioned in the topology, each spoke is dual homing, one IPsec tunnel to DC1, the other to DC2. So right now, all the traffic from spoke 1 is flowing through it's actually going through DC1, just following normal BGP rules. But what we will see is that when I send traffic to another host residing on the other spoke, in fact, let me start up a link to the other spoke to, okay, so we'll just log in here. Now it's going to come up and ask me if I want to manage this locally, because it knows it's being managed by the Forti manager rather. So I'm going to say login read write, although I'm not going to make any changes. And again, if I come here to monitor and I go IPsec monitor, I can see that there's only 2 tunnels. Again, this one is only peering with the data centers. So what I'm going to do now is I'm going to force some traffic from spoke 1. Just minimize that. I'm going to go, so I know that if I do an ifconfig here, I know that the internal IP address of spoke 1 is 30, and I know that the internal IP address of spoke 2 is 40. So if I go ping 172.168.40.101, okay. Now you notice that first ping had a much higher latency than the subsequent ones, right? Because that's the one that went out to the data center. If I come back here now and I do a refresh, there's my shortcut spoke. And you can see it's come from the external IP address of spoke 1. Again, if I come to spoke 1 here and I do a refresh, there is my fast tunnel. All right, so it's no longer going via DC1, DC2. The traffic is going direct between the spokes. Okay, so it's very brief, but hopefully it gives you the idea of you know, the operation of AD VPNs. Really efficient, gets away the whole N squared and operational overhead, N squared problem and operational overhead of trying to use full meshed VPNs, which quite honestly are a bit of a nightmare. So the next thing, and I suppose really the crux of this, is to look at the SD-WAN. So SD-WAN, as I said, is the ability to take multiple interfaces into a container interface. This SD-WAN just effectively acts as a holding point for all the interfaces that are going to participate within the SD-WAN logic. Now, I can have as many interfaces in here as I want. As you can see here, I've only just got 2 VPN interfaces, but I can add whatever interfaces I want. If I wanted to do local breakout to the internet for whatever reason, I'd add one of these physical ones here, and then I would steer the traffic accordingly. So how do we steer the traffic? Well, we create rules, and those rules basically say, well, okay, I've got whatever interfaces are contained within that SD-WAN container, and what am I going to do with them, right? So because I'm running BGP within those tunnels, BGP is control-based traffic, and I want to make sure that you know, it's always going across. So here I don't want to use multiple interfaces. Obviously, I only want DC1 to pair with spoke 1 along a single path, and DC2 to pair with it along the other path. So that's why I have only dictated a single interface there. Here I've got a rule that says if traffic is coming in that is pre-marked with a DHCP or TOS marking, now that could be because you're running a VoIP from some internal VoIP system, coming from any source going out to any destination, then use the link with the best downstream bandwidth, all right, and choose out of these 2 members. Now, I know, and I'll show you how I know in a second, that DC2 has got the best downstream bandwidth, but obviously it could go down. And in which case, even though DC1 has a lower downstream, if DC2 disappears, goes down, then clearly DC1 will have the best remaining downstream. So if I click on there, you can see here, here's my source, here's my destination. I'm specifying my protocol number, in this case, protocol 1, because I know I'm going to be using ping or ICMP to test this particular concept. I'm going to be marking the traffic with decimal 28, which is hexadecimal 1C, and that's a bit mask, just matching that, all right? And then I come here and I say, well, what are my outgoing interfaces, and what are the strategy, or what is the strategy that I'm going to use to determine which interface. So the best quality, but in this case based on downstream bandwidth. And here are my two interfaces. Now, the interfaces are put into this list based on order of preference. So the one that at the top is the one that's normally preferred. The one that's at the bottom is obviously second preferred, but that's going to be based on the measured SLA, in other words, how well it's doing, and be able to monitor things like jitter, packet loss, and latency, and whatever quality criteria that I define here. You notice if I remove these from here, again, I can swap those around, all right? They put in purely in the order that I click on them, all right? And then, as I said, parsed from top down based on these criteria. So that's something like TOS, but what if I want to use latency to dynamically look at the quality of these links? So if I double click on there, here slightly different. So I'm still saying from any traffic, and obviously I can create objects to define what traffic source IP addresses it's coming from. And then I'm saying, well, anything going to the Microsoft Skype Internet Services Database. Now you don't have to use this. I'm just have chosen to just to show the concept. And then because we are a next generation firewall, all right, we're a fully layer 7 device, we can now look deep within the applications. And if I click on here, I'll just give you a sense of just how many applications we support. You know, it's well over 2,000 applications that we support. And you can create application groups. You can group them together if there's a whole lot that you want to combine within a single rule. And if there's a particular application that we don't support because it's something that you've written in-house, then you can write your own custom application and incorporate it within that list. So anyway, it's going to come in, it's going to match these two criteria. Or rather, if the traffic does match, and then it's going to be parsed against this rule, again, best quality that I'm using. Here are my two interfaces, but you can see here DC1 is at the top this time, DC2 is at the bottom. I am using an SLA, which I'll get to in a second, which is the method by which we monitor the health of those links. And then I'm saying, well, which of the quality criteria must I use to make my interface decision? And in this case, I'm saying the link with the lowest latency. Right, cool. And the rest of the similar concept, as you can see here from my list, I've got YouTube, and then I've got that which I was just playing around with, which I'll show you the purpose for that in a second. Now here's where we have our performance SLAs, and here's where we're actually looking at the two links, and we're looking at the characteristics of those links in terms of their health. And you can see that both of them have got 0 packet loss. You can see that the latency between the two varies quite considerably here. And you can see both have got a bit of jitter, which is expected, but still DC1 is performing better than DC2. Now, if I just drill down into that, you can see you've got your options. Now, we do actually have other options, which I'll show you on the management platform. These are just the two that are presented from the actual platform GUI. I choose a server. In this case, I'm being lazy and just choosing good old Google. Here are my participating interfaces, saying enable probe packet, which is that. And then I am choosing an SLA target. So what is the latency threshold? As long as it's under 18 milliseconds, and as long as the jitter is under 200, obviously that's wildly high, but again, it's just for the purposes of demonstration. Check every 5 seconds. Now we can go as low as 500 milliseconds here. If I see 2 failures, in other words 10 seconds, declare that link down, and only declare it healthy again when I see 2 successful polls. Now, with respect to this, you must choose, or a customer must choose, how aggressive they want to be, but you must also consider that if you have transient flaps in a link, it may not be in your best interest to have traffic flipping and flopping between links, right? So, but again, that purely depends on business need and your application requirements. And you can see here, even within this window, I can still see how the current values are performing. So that's the SLA that I'm using. And I can click along here and see just a quick brief snapshot of which interfaces are in the SD-WAN and the traffic that and the load that's on those links at the moment. Now, SD-WAN and steering of applications is all well and good, but what happens when you go down to a single interface and all of a sudden all those applications are contending for the single application, for the single link rather? Well, that's where our traffic shapers come in. And our traffic shapers allow us to again use all those same criteria, things like TOS, things like application awareness, to actually create shapers and apply those shapers to traffic. Now, the shapers are effectively a dual leaky bucket type environment where you have two thresholds. You have a guaranteed bandwidth, which will always be applied to the given traffic, and then a maximum burst profile that says, okay, well, if nothing else is using that, and if I've got headroom to burst, well, then allow that to burst. But if there is traffic running and there's contention for that bandwidth, then that's the absolute minimum these will get, and in which case they won't be allowed to burst to those levels. If I come down to my policies, we can then see the traffic shaping policy. And here is where I'm applying the application awareness again. So I've created the shapers. Now I apply those shapers to a policy, or rather apply a policy to those shapers, whichever way you want to look at it. So here I'm saying any source traffic going to any destination following any service, but being application matching Skype audio as per before. And again, the same list of applications we saw previously. Then apply the shaper to the outgoing interface. Now, although that's the container, it's intelligent enough to know which of the interfaces are going to be affected by this particular shaper. And then in this case, I'm using a shared shaper in both directions, which basically means all traffic which matches these criteria will be bound by that shaper. Now, I could do a per IP, which would create shape traffic per flow, so per user, if you would. But you know, normally on a sort of a WAN link, it kind of makes sense to do this. So at least you know what your given bandwidth is, and you can shape all your traffic accordingly. But we provide you the choice. Very flexible platform. And if I can, in fact, you know what, I can actually put that in my favorites, so I don't have to drill down here. We've got this capability called the favorites here. And where I can see my IPsec monitors, I can see my traffic shaping profile. And what's really great, I think I briefly mentioned it previously, was the Fortinet Fabric. The Fortinet Fabric is a model whereby, as I mentioned earlier, each individual FortiGate can manage a fabric of its own right. So that's a collection of switches, access points, internal capability, and so forth. But then we can have a God fabric, basically a fabric master or a fabric of fabrics, where all these downstream fabrics inject in their view of the world into this. So this central fabric is a single pane of glass where you can go to at any one time and have a view of the entire fabric. So devices that are connected to it, what switches, what access points, and so forth, how they're doing, whether they're up, down. But most importantly, threats. So any threats, any IPS rules, AV rules, web filtering rules, whatever that are triggered will show up here as well and can be acted upon dynamically by using something we call our automation stitches. And the automation stitches are where we can take triggers, whatever those triggers may be, and we can then create actions around those triggers, right? So, you know, I could use a compromised host. I could then say, well, okay, if I get an alert saying somebody's triggered an AV rule or something, what do I then do? Well, maybe I want to send an email to the security ops people. Maybe I want to knock them physically off the network, or maybe if they're coming in via VPN, I want to ban their IP address. And what if they're doing something in the cloud? Maybe I want to run an AWS Lambda script to knock them off there, or shut something down, or take some function in the cloud. And if you're using our EMS, we can quarantine them using that as well. So very, very powerful. Even run CLI scripts if you so desire. So that's the automation scripts. But as I said, it also allows me the ability to look at certain things. So here I'm on DC1, I'm looking at the IPsec tunnels on DC1, but I can also pop down here and I can look at the IPsec tunnels on spoke 1, on spoke 3. All right, so it gives me, as I said, that central pane of glass, which is over and above the central pane of glass that the central manager provides me. It's just a really a powerful way of getting full visibility. And really, at the end of the day, there is no security without visibility. But if you want to know more about the fabric and its capabilities, again, please reach out to your assigned Fortinet rep. So what we're going to do is just come back here, and I'm going to show you the SD-WAN doing its job. You can see here, if I look at the traffic shapers, you can see I've got low priority traffic running, and that's my normal web traffic that's coming from that host. So basically that is not matching any of these rules. And what I did forget to mention was on the SD-WAN rules here, anything that doesn't match these rules will then hit the default rule. And the default rule will then say, well, look, I've got n times number of interfaces. Why don't I use them? Okay. And all that best effort traffic can then be, you can then say, well, load balance it across those links on a source, on any one of these methodologies, algorithms, whatever you want to call them, all right? And then what will happen is, as I said, it will spray the traffic intelligently across the given links, but they'll be defined as it is here as low priority, and in which case it'll basically be best effort because it's not matching these. So if I come along to my little Linux machine here, and we go back here, and what we're going to do is we are just going to clear that screen for a second because we don't need that anymore. I've created a simple script here, and that script basically says ping that IP address, which I know is the far end gateway for my network. Mark the traffic, quos mark it, digital 28, which decimal 28 rather, which I know translates to 0x1c, and then send a certain packet size. This is irrelevant. That TOS marking is the most relevant. So if I run that now, all right, so now I've got that traffic flowing. If I come back here and I just refresh that, there we go. You can see the shaper has detected there's traffic hitting that link. Now, that's all well and good. Let's go back to those SD-WAN rules, and let's see here. It said TOS, all right? Anything that matches that, use the downstream link, which should be DC2. So if I come to my FortiView, my destinations, which is going to show me all my applications as well as my traffic, here we go. And I'm going to drill down into that. So my traffic's coming from spoke 1. There's my source IP address. It's coming from that machine. If I click on the policies, it'll show me which interface. And there you go, DC2, right? As we expected. So let's go back to my traffic shaper now. And let's fire up some, we'll leave that running. Actually, I think I had YouTube here. Let me fire up some YouTube traffic here. Get some video going, and let's come back here. Oops, wrong screen. And let's refresh that again. And there you go. I've got best effort, because obviously what I've got is I've got all the other HTTP YouTube traffic, which is not the video and which is not the audio that's going through. And I've got the YouTube video and audio traffic here being detected by the shaper. And if we go back here to the FortiView destinations, there's my video play there. And let's look here, and there you go. It's going along DC1, right? Which I expected it to, because once again, if I come back to my SD-WAN rules here, it said, if you remember, YouTube, use upstream, which is got the highest upstream, which is this one here, which is, if I hover over, you can see that DC1 has got a higher upstream, which is 1 gigabit per second, versus DC2, which has got a upstream of only 10 kilobits per second. Now, that is traffic engineering. It's not affecting the actual bandwidth of the interface in any way, shape, or form. It's just an artificial traffic engineering that I have placed on that. So let me show you that. If I come to the interfaces here, our VPN interfaces are full route-based tunnel interface, so pseudo-wire, if you will. All right, so don't confuse these with policy-based VPNs. these are true layer 3, and this is how the BGP is flowing, and we don't need to run silly GRE tunnels to support things like multicast traffic. It's all natively supported within the IPsec. So here you see I've just artificially put in these upstream and downstream values, and that's just so that we can traffic engineer the traffic within the SD-WAN rules. So now what I'm going to do is I am going to set up a, let's just come back here to my traffic shapers. I am going to fire up a Skype call from my Skype on my mobile phone to this. All right, if I say okay there. All right, so now I've got a call running between my phone and this machine. So let's go back here now. And here I've got Skype. Okay, so now you see that the traffic shaping is detecting all that traffic. If I come back here to my FortiView destinations, there's my Skype audio. Okay, see that? And if I come to my policies, it's going via DC1. Why? Because DC1 has got the lowest latency. Again, okay, so remember what I said here. Use latency as the criteria. DC1 is my preferred. If I come back to my performance SLA, again, we can verify that. All right, DC1 has got the lowest latency. And now, if you look at that FortiView destination, I actually phoned in from, this is my external IP address. Now, please don't start trying to do a DOS on me, but that's my home IP address. So I phoned in from that. This actual setup is sitting in a laboratory, which is a good 50 odd miles away from me. So the traffic came in externally into the SD-WAN interface, but the FortiGate was still able to detect the application and steer it along the given path. All right, so if I look at this now, which is the Skype control traffic, now what you'll notice is that the control traffic is going along DC2 because it's not part of the applications that I defined within here. Here I just defined the Skype audio, Skype video, right? The actual Skype control channels weren't that. So, you know, all the other stuff, Skype portals and so forth, are going via DC2, and the Skype audio is going via DC1. Cool, so hopefully that's given you a good view of the Forti SD-WAN capability. And once again, I reiterate, if you want to see more, if you want to see this, if you want to play with it, you want to demo it yourself, and just make 100% sure in your own mind that I'm not doing any sort of smoke and mirrors here, reach out to your Fortinet rep, and they'll be more than happy to provide you a demo on this. Now, if you're already a Fortinet customer, the good news, you don't have to pay anything more. It's not a licensable feature. You simply turn it on. That's the value of being a Fortinet customer. All those advanced features that I showed you earlier are just a value add. There's no creative licensing. There's no extra charges. Just go in and switch them on. There's WAN optimization as well as on our platform. So if you want to use SD-WAN over LTE or other slow circuits, VSAT or whatever, we've got WAN optimization as a value add feature capability on the platform as well. So to manage all this centrally, it's all very well and good, you know, me showing you from the device, but the device is only going to take you so far, because if you've got many thousands of them, you want to be able to manage them from a central pane of glass, and it would help if I went to the right administrative domain. So FortiManager is a multi-tenancy environment, so we can have multiple administrative domains, and within each ADOM, you can be managing a completely different geography, groups of firewalls, switches, APs, so forth, right? So here's my AD, VPN, SD-WAN, and you can see here's my devices. I can click on any one of those devices, and it'll show me you know, all about the device, its IP. I can manage its routing, its WAN optimization. There you go, what I've just been telling you about, VPNs, and all this sort of stuff here. Here's my spoke one, and again, same things. Here's all the capabilities I can manage, all right? I can manage my policies from a template perspective, so I can have a template to push out. So here's my spoke to site templates. Here they are here. And if I look at the actual template here, it's a very simple one. All right, you can see that. And if I come to spoke 1 here and I look at the policies, you will see that it mirrors exactly what I've got on here, right? And it'll be exactly the same on spoke 2 because I'm using the same template across both of them, okay? Now, the same is done with the SD-WAN. So I can come along here, I come back here, I go to SD-WAN. Here are the devices, assigned devices. These are the devices that I'm going to manage via the SD-WAN templates here. I create a template. And you can have as many templates as you want, and you can be assigning different templates to different devices. It's up to you. Obviously, this is just a simple demonstration. And again, this is representative of everything that I showed you earlier. Here's my interfaces. Here's that health check that I was doing, and here's all those rules. There's that test rule that I showed. So what I'm going to do now, I'm going to delete that one. I'm going to say OK there. All right. I'm then going to say install. It's going to say install device. I haven't changed any policy settings. I've only changed the device settings. It's going to say, okay, well, you want me to send it out to all those devices. So let's just go along here. Let's go to my SD-WAN rules. And you can see there's my test rule. If I come to spoke 2 here, and I come to my SD-WAN rules here as well, there's that test rule. So now what we're going to do is we're going to push that change. Okay, now it also allows you to look at the history as well as the logs. But what I should have shown you before I clicked install there was it also allows you to see what changes are actually going to be sent to the device. So you can check that for a sanity check, and you can change it if you realize you've made a mistake. And we do a rollback function as well. We store multiple versions of the previous configs. So if I click finish there now, and I come here and I refresh that, you can see that rule is gone. And once again here, that rule is gone there as well. I can also monitor the SD-WAN from here. So I can get a table view here. Okay, and here we can see that I've got my 2 links. We know that the one that's in orange is saying, well, this one is deviated away from the acceptable SLA. We know that because we saw that the latency was very high. Everything here is green because what that's saying is that both links are up and working. So I could send traffic down both of them if I desired. But you see when I hover over this bottom one, it says, well, actually, it might be up, but the SLA is not conformant to that particular traffic type. And I can drill down, I can get a lot more information regarding this. I can look at the trends, the bandwidth trends and so forth. I can come down here and I can look at my traffic overviews, my latency and my jitter over a period of time. There we know there was no packet loss because we saw that earlier. All right. Now, I haven't done it yet because this is just running in my lab, but if you install the GPS coordinates within here for your devices, then it'll show you geographically exactly where your devices are. It'll show you exactly the network topology that has been that you've deployed. And again, you can come and hover over each one of the devices and see why, in this case, they're all orange because all of them have an SLA which is failing, and this, as you see, because of that latency. So you had a very quick snapshot of the day in the life of your SD-WAN. So hopefully that's been useful. As I said, it was only meant to be a very brief overview. The platforms are extremely capable, extremely powerful, and there's just simply too many functions for me to go over in a short video webinar. But I'll say it again, you can get more information from your Fortinet representative, including, sorry, I did forget to mention, let me go in here because I think this is worthwhile, is the reports. So we have full reporting on the platforms as well. And you can come along here and get a full report on your SD-WAN, how it's performing, applications. And there's a myriad of different criteria you can incorporate within the report. These are just the few that I chose when I quickly built this template. But it's very, very feature rich. There's loads of templates, loads of chart libraries and so forth that you can use to generate reports, not just for SD-WAN, but remember, we're a multifunctional security platform. So you can generate reports around things like your cybersecurity. So I've got one here called our cybersecurity threat assessment, and here you can get a full view of what threats have your devices have encountered, and this will be all your devices. Remember, I spoke about that fabric, so you'll get a full view about all the devices, your entire security domain, and the reasons why. If you're seeing any alerts, why they're critical, and things you can do to mitigate your threat exposure. So once again, thank you very much for your time. I hope that was useful, and I bid you farewell. Thank you very much. Goodbye.